So before starting, I would like to present myself. My name is Alisa Hrustic, and I'm from Sarajevo. I work as a test automation engineer at System Verification Science since last year. So I'm sure that you already heard about our company, which is the global quality assurance company, specialized in providing advanced services like a test management, test automation, quality monitoring, and I hope in the future also testing using artificial intelligence. So let's get started. Okay, so I'm sure that all of us is hearing this buzzword, artificial intelligence, very often these days. So it is completely okay to ask ourselves what artificial intelligence is. So according to Google, if you search for a term or for a term artificial intelligence, the first thing that you will find out that when talking about artificial intelligence, people think of robots. That's normal because there are many high budget movies and novels that are making movies about human-like being machines that are walking on earth, fighting with humans and stuff like that. And that's kind of funny, but to be honest, it has nothing to do with the truth. So if not that, then what artificial intelligence is? To keep it very simple, artificial intelligence is a computer system that is able to perform tasks that require human intelligence. It is based on a principle that human intelligence can be defined in a way that machines can mimic it and can execute tasks, from some of them that are very simple to those that are even more complex. Some of the basics of artificial intelligence include learning, reasoning, and perception. And basically that, in some short definition, is what artificial intelligence represents. It is also completely normal that our next question is, do we already use artificial intelligence in our daily life? And if yes, how? Well, the answer is probably yes, you are using some of the systems that have artificial intelligence already applied, but you are not aware of it. So let's see some of the examples. If you take a look at this slide, I'm sure that you can find at least one segment and one example that you are using artificial intelligence in your daily life. So let's get started example by example. Social media feeds. We are living in the age where everyone has at least using one social media or even more. And if you are using it, then you must be aware that everything that you see on your feed is actually presented you by artificial intelligence. How? Artificial intelligence is using your behavior, your past behavior, your searches, your reactions, and stuff like that. And it serves you what you want to see on the social media. And that's why we are, let's be honest, so addicted to the social media, because we are seeing what we want to see. And that's not just like that. There are something behind that. And that something is called artificial intelligence. So next example is smart cars and drones. In my opinion, this is the best example of how artificial intelligence is being used in a real world. For example, just a few years back, we couldn't even imagine to have completely automatic cars. And the progress that companies like Tesla did so far are really impressive. For me, it was very interesting to know that all Tesla cars are connected and they are communicating one each other by sharing their experience, and based on that experience, they are learning. So that's the base of the artificial intelligence, to learn things and then to behave. Then we have online ads network. It's probably something that couldn't even exist without artificial intelligence. And this is basically similar to the social media feeds, because online ads network that are served to us are served based on our preferences, our searches, and stuff like that. And it would fail without artificial intelligence, because some ads would maybe served to you that you don't have preference at all. The next thing is banking and finance. There are many areas in banking and finance system where artificial intelligence is used. For example, customer service. The AI algorithms are used there. But also there are other mechanisms that are deployed in order to predict and to prevent frauds and stuff like that, which is really important. And also there is another very important segment, and that's healthcare. There are many ways that artificial intelligence is helping healthcare in terms of a better in terms of a better job management in general, but also using some analysis and predictions. It is easier to have diagnosis and other related informations to the patients. So there are plenty examples out there on how we already use artificial intelligence, and this is our reality. We must be aware that there are already complex, very complex software systems that are being developed, and they need to be tested. And that's where the software testing comes. This is definitely new age of a software testing with artificial intelligence and machine learning. And why? Because software development has changed according to applying artificial intelligence models. So the software testing has to be. We will have to apply some new approaches and forget about some old approaches and ways that we were working. The key value proposition of artificial intelligence and the way that it can benefit software testing is that it can reduce direct involvement of the human while performing some tasks. And that is really perfect, because if you have your, for example, automation frameworks or some other tools that are using that can perform something that you usually do, you will save your time. So there are many changes, as I mentioned, but let's see and go through just a few of them. We are going to do more visual automated UI testing. When it comes to visual testing, here we are talking about testing where you're validating that your UI really looks perfect in terms that position of a button didn't change, or a color of a button, or all elements on the page are looking good as it should. With the test automation tools that we currently have for, let's say, traditional automation, these types of testing are very, very hard to automate. So this ends up always being a task for manual tester. So for that, this is a perfect fit for a test automation using artificial intelligence. Next thing is the testing APIs. And you will probably say, but we are already testing APIs, so what's the change? Yes, you are, but this is something different. First of all, when testing most of the machine learning and artificial intelligence software products, you will be without a user interface. So you won't be able to validate changes. You will have to test only APIs. And you will have to learn about models that are used in the artificial intelligence product that you have to test. Otherwise, how can you know that your result is a good? So we will have to learn more about modeling, about machine learning in order to perform good tests. And also our scripts will look probably different. Next thing is running more automated tests that matter. We all have our set of tests that we are executing if we need regression test list, if we need a sanity test list, and stuff like that. But to be honest, how do we decide what's regression test case and what is sanity test case? We have some knowledge of the application, and we make some assumptions there. But the reality is that even we have prioritized our tests by ourselves, and probably most of them is okay. We cannot be completely sure that the change that was done by developer is going to be tested with the test cases that we selected. So in that case, it would be perfect to have a tool who is going to analyze the change that developer did and who is going to select the minimum number of test cases to execute to make sure that that particular functionality works. And next thing is spidering AI. For me, this is one of the most interesting change that AI will bring. And that's because it's a completely, let's say, new term. Some of them we already know about. Spidering AI is basically a principle in which we are going to have tools, AI tools that are going to analyze our applications, and they are going to create tests for us. So those types of tools will probably, let's say, listen and save a lot of data for example, our application, including screenshots, how the application looks like, HTML, how it looks like, and it will save that to some database. And in the case of some change on UI, it will analyze it, and based on what already learned, it is going to predict some of the test cases, and that is going to be very, very useful. So we can say that artificial intelligence is pretty powerful. So is there any challenges there and something that artificial intelligence can't do and still rely on a human intelligence? And the answer is yes. One of the most, let's say, important challenge when it comes to testing using artificial intelligence, and especially in the area of test automation, is how to decide what to test when it comes to new features. For example, you know from your everyday job that in order to select something as a good use case and as a good test case, you have, let's say, some kind of project documentation, you have a requirement, you have daily meetings, and you gather information, you learn about the system, and you are able then to have a good use case that is going to be tested. But when it comes to artificial intelligence, currently, most of the artificial intelligence relies on predictions that can do on a previous behavior. So if you have a new feature, you don't have a previous behavior there, how AI is going to do the work there? And that is one of the challenges that is not overcome yet. So new age of the software testing is going to bring new tools. That's logic. And there are already tools out there that we can use to start our process of automation testing using artificial intelligence. And I need to say that when it comes to this topic, in general, everything is still in an early phase. It's not yet adopted by the people, but there are tools that you can go and play around a little bit and to see what they can give you and how can they maybe improve your current process of working. So here I've listed several tools, and for example, for me, the most interesting while playing with it was a test team. Testim is a tool that is going to help you to select dynamics, identifiers and locators of your application. So we all know that when we are writing automation tests for a UI, we need to identify elements to find their IDs and to find their names and to save that somewhere and to reuse that in our test. But what happens if developer do the change on, for example, just the name of the button, and instead of submit, it is done or something like that, our test is going to fail, which is not okay because functionality is working and we need to go and to fix that in order to have the test up and running again. So what testing is doing, it is when initially, let's say, scanning your application, it doesn't take only one, for example, ID or a name locator of your element, but it takes the whole HTML of that element. And in a case that developer changes, just the one change, for example, changes the ID, the testing will compare the new HTML and the old HTML. And if the only change is that little one change that developer did, testing will say, okay, this is the same element and I am going to dynamically update the new ID or the new name, and this test shouldn't fail. And this is really great because lots of automation engineers are, let's say, wasting their time because of these small changes that the developers do. Okay, so we can conclude that artificial intelligence is really great and is going to help us. But let's see one real example that I have and that I'm going to try with the help of artificial intelligence. So currently I'm working on a project where we are doing some changes. And I have my automation tests that are up and running, and they are executing on a daily or nightly basis on each commit, and everything works fine. But sometimes I experience that tests fail due to some unexpected conditions. In my particular case, I'm receiving a 404 not found error. I contacted my manager and he told me that that's fine because currently there are some changes that are being deployed to the test environment, which I use as a default environment for my test execution. And then he said, you should execute your test on staging environment. And if it works on staging environment, it's okay that it fails for the moment on the test environment. Do not fail your test. So what I need to do in that case, in the morning when I start with my work, I see that my test failed. I need to open test result to see the failure. Okay, it's a 404, that's okay for the moment. I need to manually change configuration to start test execution again. Okay, it passed, everything is fine. But why do I need to do this manually? It would be so good that my tool knows that it is okay to fail on a test environment. And if it passes on a staging environment, that's good. I would be very happy if my tool was so smart to do that. So my problem is that I need to waste my time every time when I have test failures to analyze and fix each failure, even if some of them are constantly repeating. So what is my solution then? My solution is to build and train AI using machine learning that will help me. But how? How can some model can help me? Well, if I have a test which fails, I would like to know why it fails. And that's something that I can know regarding the history of test. I can predict that value why it fails. And if it failed with a 404 error, please execute on staging environment and don't waste my time to fix that. Okay, so that's idea. I should use the model that will predict error failures. So from where do I start? How to build machine learning model? Well, I definitely need some tools, a lot of tools. And here I have listed the tools that I've used for this example. So first, I'm going to use RapidMiner Studio, which is a data science platform that you can use to build and train your machine learning models. Reason why I have selected RapidMiner is because it has a free version for small data sets, and my data set will be small comparing the data sets that you will use in let's say, real life. And it has all components that I need for my model. After that, I'm going to use MS SQL database to store my input data and to store my output data, so I can decide what I'm going to do with the output data. And in the end, I have Selenium C# framework, which is going to be even smarter now because it will run tests instead of me when they fail. Okay, let's now move to RapidMiner Studio. Okay, so this is basically machine learning model that we are going to use. This is already a done solution, so I'm going to start from scratch so we all are on the same page. So as I said, I want to have machine learning model which will, based on the input data, predict why my test failed. And based on that, I'm going to perform some action in my test automation framework. So in order to start with that, I need to have input data set. And my input data set are test results, which is a test name, test results, and date of execution. And of course, test results can have multiple columns. That depends how you selected and how what kind of informations you can have in your data set. For purpose of this demo, I have created a table and inserted data, but you can find other ways depending on where you are running your test automation, where do you store your result, and stuff like that. So to start, I first need to create connection from RapidMiner to MS SQL, and I'm going to do that by clicking on import data, and I'm going to select database and add a new connection. Database is here by default, and I'm going to write some name like read test data SQL, and I'm going to create. Here I will select some values that I need. So in my case, this is a Microsoft SQL. I'm going to leave these things as it is because I'm using my local server there. And I'm going to use a database that is created, and this is a test. And I'm going to save this. And if you go to connection that we just created and your test connection, it works, you will click then on next. And here you are actually building a query to create a data table. You have the list of all available tables from MS SQL server that you are connected to. So for this purpose, we need to use test results, which has 3 columns. It has a test name, error, and the result date. We are going to select all of them and click on next. And we are going to save this. So basically here, what's done is that data is selected from the database and it is imported in the RapidMiner Studio. You can see here that we have a test name, we have an error, we have a result and stuff like that. So basically this is the history of the test execution. Okay, great. Using this tool, you can see some other parts like statistic if you would like to know, test name that fails the most, or if you would like to see the error that test is failing the most. In my case, you can see it's a 404, the issue that I'm trying to resolve. Okay, now we can start by building a model. I'm going to add this component here. As I said, RapidMiner is a very user-friendly, and if you are beginner in creating machine learning models like I am, then it's a perfect solution. Okay, once we selected the data, the next thing that we need is to split data. Okay, so what does that mean? This is very important in creating models. When having an input data set that you are going to collect the split data component, you need to divide the data into two parts. One part is the data that you are going to use for training, and other one is the data that you are going to use for testing. So we are going to do that by clicking here and adding a ratio. And this is the ratio that I'm going to use. And save. So why did I select 0.7 and 0.3? These are some of the best practices when generally splitting the data. 0.8 and 0.2 is completely okay too, depending on how your data set is large. But the rule is that the training data, it must be greater than testing data. So you need more data in order to train your model correctly. And then you are using the set of data for testing to test if your model behaved as it should, as it was trained to do. Okay, now that we have data, we split the data. Now we need to use an algorithm that is going to do calculations for the predictions for us. And for this case, we are going to use naive Bayes. There are several reasons for using naive Bayes in this particular case, and I will say a few of them. First thing is that naive Bayes algorithm works very well with small data sets, and my data set is honestly small because it's for the demonstration purpose. Also, naive Bayes, some standard use case involves text categorization. So it doesn't, in our case, in the input table that we are using, important columns for us are test name and error. So both of them are strings, and naive Bayes is a good to work with them. And also, naive Bayes is algorithm where we made one simple assumption, and that is that labeled data, and that is the data that we want to do prediction for. And in our case, we want to do prediction of an error, is not depending on any other data in the table. And that's also our case because data set is simple and I don't have dependence between test name and test error or date of execution. Naive Bayes has one input parameter and two outputs. Input parameter is a training set of data. So I'm going to connect split data first output, which is 70% of the data, and I will then use 70% of the input data for the training process. Output of the naive Bayes is a model that can be applied to unlabeled data in order to generate predictions. And the second output is an example set. It's a list of the test name and predictions that we are going to have. Now we will add next component, and that is explain predictions. So this component, this operator actually identifies the attribute that play the largest role when making a prediction. So in our case, that is going to be a value from column error. It has several input and several outputs. It will take the model from the naive base. It will take the training data, and it will take the rest of the data, and it's a testing data. So explain prediction is going to make a test data, let's say a test data with prediction, and it's going to use that remaining part of the data, which is a test data, to test if the model behaves good. And basically, this is the model which is done. We can now complete this model by connecting to the output value. But because I want this data to be stored to my MSS SQL database so I can manipulate and work with that data, I am also at write database. And basically, the result is going to be written to database. So this is the model done that I actually can now execute. So I'm giving the input data, I'm splitting that data, I am using these two components to make some calculations and predictions for the value that I want, and then I'm writing the data to database that I can work with then. So I should start now this model, but I won't because I'm going to start other, which is the same, but it is tested, and I know that it works. Okay, so let's execute, and this is the result. New table is going to be created with the name of tests and prediction of error, and also confidence level. So what is confidence level? Confidence level is basically probability that something is going to happen. In our case, this is probability that the first, for example, first test from the list is going to fail with this error. And we have a confidence for each error here. And the confidence that, or probability that this test case is going to fail with error 1 is a 0, which is logic because I don't have even one record in my data set where this test failed with this error. So these results, now what I need to do with them is I need to group results by a test name and select prediction for error which has the highest value of confidence. And that is something that I'm going to do in MSS SQL, because now that I've executed this, this is written into my database. And this is a database. So this was input, very simple input. And this is output, the same thing that we just saw there. So next thing that I need to do is to create store procedure. Store procedure is going to return predicted value given for the given test name. So if this is the test that is failing, I want to know why it is failing. So when I execute this, I'm going to get this error. So if this test failed, it probably failed with this error. So if I know that, I can do something about that. So I avoid my manual tasks. This is a very simple store procedure in which I'm creating a procedure which takes a parameter, which is a test name, and return the value of the predicted error. How do I do that? I select max value from all confidence of error values that I have in my table, and they should be greater than 0.4. So also this is very interesting value. And how do I get this value? There are some, let's say, best practices and rules on which prediction is considering as a good prediction. And if you have value between 0.3 and 0.5, that's a good prediction. You can believe to your model. So for this example, I skipped calculating this value, which is, by the way, calculated using natural logarithm. Why I did that? Because the value is calculated based on the distribution of the positive of the pass test and the fail test. If I was using that in that case, my input data set would be really large, and I wouldn't be able to use RapidMiner Studio. But this is a value that can additionally be calculated also by creating a new store procedure, but for demonstrational purposes, we will assume that it was 0.4, and that's completely okay. So we have a model that is trained and it can predict values for us. Now, when my test fails and I know why it failed, then I can do some action how my framework should behave in that case. So let's see that. And this is a framework. These are test cases. Tests are very simple because the goal is to present one idea and possible solution, and not to discuss too much about some complex use cases and stuff like that. So I will first show how this test is going to behave if I comment out the artificial intelligence part in the text, in the test. So basically, I will start it, and this test should fail. And this is actually the problem that I described at the beginning of the presentation. It failed. Why? Because I'm expecting to see some header value that I can validate, but instead of that, I'm receiving 404. So let's say I'm at my work and I see this error. I know what to do. I need to go and change configuration and run that on staging environment, and then it will work. So I want to save that part of my time and my human interaction there. If I know why my test failed, then I know what I need to do inside my framework. So framework can fix that. So what I'm doing here is, once the test completes, not completes, after execution is done and before completing everything, I go to tear down and I take status of the test from the test context, and I'm validating if the test status is a failed. And in a case it is, I will call the rerun failed test. What is inside rerun failed test? Inside this method, I am calling perform test action for a currently failed test. So what's perform test action? It is actually one method that is going to say what to do in a case test fails. So I am calling this method and I'm giving a test name. Inside this method, I'm calling the my MS SQL database using this method, and I'm saying, hey, this is a test name that failed. Do you have prediction why it failed? And it will connect, and it will find if there it is, and it will return me some value, and that's some predicted error value. And here there is just a simple switch case block in which I say, okay, you returned this value. I am going to handle that in my test. So for example, if my test failure is a page not found, I'm going to change configuration settings, and I'm going to start execution on a staging environment then. In that case, my test should work. Okay, this is something that I am repeating this again, is the thing that I'm doing manually. But now I'm saying to my framework, If you know why test failed and I'm telling you what to do without my interaction, please do it and rerun this test on staging. So I'm going to, it is commented, I'll remove the comment now, and I'm going to start this test again. Initially, it will fail again, of course, because I'm still facing the 404 error. But after that, it will rerun on staging and it should pass. So let's see that. And it worked. It's green. Great. So here you have a trace, which is really important. So you know that initially when started to execute on a default environment where you execute your test failed. But now your automation framework is smarter and it knows, okay, if this test failed, it probably failed because of that and that error, and I'm going to do that and that. In this case, rerun on other environment, and here you are seeing the test pass after rerunning it. And this is great because when next time my test fails with this error, there won't be any of my interactions. I can speak with about that with my manager in a terms when are we going to have stable test environments again and stuff like that. But my tests are working. I don't have to investigate what is going there. So that is basically just one example. You need to know how your tests are behaving in order to have case for, let's say, each error. I have here also one very interesting example. This test, if you run it without this artificial intelligence part, is going to fail because it will receive the error that element is not clickable at that moment and other element would receive the click. And I am completely sure that anyone who used Selenium experienced this issue. So what do we do in that case? We are frustrated there because sometimes it is working and sometimes it is not. And we are trying to add some, let's say, weights, implicit, explicit, waiting for elements to be visible, but sometimes we cannot avoid errors to happen. Selenium click does not work well. In that case, we need to other solution, and that is to use, for example, JavaScript executor to click on particular element. And that's okay. It's important that it works. So in this test case, when this test fails, I'm going to also contact my database and it is going to say, hey, your test is failing because of not clickable error. So you should use Selenium part. So you should forget Selenium part and start using JavaScript executor. So let's run this test as well. I'm not going to execute without this self-fixing. We are going to have trace anyway. And that's great. Here it failed because you see element click intercepted, but then it started again and it passed. And that's really great. So this is the way I saved my time for investigating and doing manual triage for at least 2 tests. Can this be applied on whole framework? Yes, it can, of course, but you need to handle that in your frameworks. You need to have enough test data so you can get a good predictions. So it's very important when using this approach to know that it's not enough to have test execution from the last month, because in that case your test can fail, and since you don't have enough data that you are training and that you are testing, you can get false prediction, and then you may fix your test somehow, but the error was something other, and that's not okay. You want to have confident tests. So in order to have that, you need to have a lot of data. And of course, you need to tell your framework what to do in a case test fails. So for this example of the different environments is applicable in my framework, because I know what to do in a case test fails with that error. Other tests and fix for other tests can be applicable for any type of framework, because this is something that it's not related to the, let's say, current situation on my environment. It's more the situation that some of the Selenium functions failed to act as we expect them to work. So basically, that's it regarding the demo part. I had a problem and I resolved my problem. So I don't have to do manual triage when these tests failed. Okay, so.
Okay, should we go with the Q&A?
Yes, we can actually. I have just a few more slides to complete. This is the model, just to confirm once again the components that are communicating. We completed the demo, and here is the conclusion about software testing and artificial intelligence. The main conclusion is that we need to learn how to work smarter and not harder, because as more and more AI comes into our lives, the need for testing with artificial intelligence is increasing. We need to change our approach and to learn things to be on track with everything. So basically, this is it from me. Thank you very much for your attention in my name and in the name of my company who supported me to do this webinar. And we can now move to Q&A section.
Okay, so there were some new questions on the chat in the meantime. So we'll start from the first one asked. This was asked. The similar question was asked in the first session as well. So how often do you need to refresh the data sets that are used in automation? Basically, do you need to create to update the data sets after some
okay.
time?
So basically, that depends. If we have already existing set of tests that are created, and so no new test cases, but test cases that are already in our data set that we used initially. But it's completely okay to have, for example, updating the data set once a month, but that depends on how often you execute your test case. In a case you have a new test cases written and you want to include those test cases now in a learning model, then you shouldn't go easily with including a new test, because in that case, if you have one test case and just several results, okay, you will get prediction, but that prediction may be false because you need a lot of data so you can have a good level of confidence for your tests.
Okay, I hope that answers the question. The next question would be, how hard would it be to implement AI testing of visuals, for example, maps?
Well, I think very hard because The solution that I've presented is an idea how you can improve your current frameworks, and most of the test engineers are using Selenium as a base. And Selenium currently does not have, as far as I know, any support for the AI. So when it comes to visual testing, especially the maps, there are new tools out there that should be used. So basically it is possible, but it's a new age of tools, and I don't think that those tools are still good and confident enough that they can be used for maps, because maps are also set with lots of data sets and with lots of details, and probably it's still hard to implement that part of the automation.
Okay, I hope that answers the question. So the next one would be, is there a way to learn the AI to run different scenarios depending on the type of a mistake?
To learn the AI to different, well, basically, yes, and that's something that somehow it's shown here. So, for example, if you but I think here is the same test, I guess, to learn different scenario. Um, Basically, what we have currently is a prediction why probably test failed. And based on that prediction, we can perform an action. If we assume that they may be, for example, 2 or 3 different errors for our test, then we should include that level of complexity in our automation framework. It is possible, it's just that from the predicted value table that we have, we will not use only one predicted value with the maximized value, but we will use, for example, top 3 values of a confidence error. And based on that, we are going to do something, if it's possible, to fix each of them in the test framework.
Okay, and the question that I skipped over was, just a second, yeah, this kind of approach with retry failed test cases is going to increase time of test execution. How to improve that?
Yes, it is definitely increased time of the test execution. With this approach, we need, let's say, accept that execution time will be a little bit longer than usual. What we want to save here is our manual time and our human tasks that we are doing. Other thing that could be implemented is we could give priorities to our tests. So not each test has the same priority. So if we are running a regression test list, or if we are running any tests where time is very important, then if we can rerun only tests which failed, but which have the highest priority. So if I have, for example, 5 failed tests, and 2 of them have a priority 1 and the rest of them have a priority 3, for example, I will say, okay, I don't have time to validate everything. I'm going to execute only the tests with the highest priority. So we can do that to improve, but with this approach, the goal is to avoid human interaction.
Okay, I think those were all the questions that we had so far. There is one more question, last moment. So did you come to some other tools similar to RapidMiner that could be used in similar situations?
Yes, definitely. Basically, RapidMiner is good for a new new users for user who just started to working. But when it comes to building the model, there are very powerful tool called SAS, but it's very expensive. It's very expensive. Also, there is R. It also, I think, you need to pay. It's not open source, unlike RapidMiner. And if you are very good in programming with Python, then you can create your own components. You can develop your own components and then use them in the model.
Okay, one more question. Yeah, I just want to add that usually the tools with the user interface, for example, MATLAB, I use that before they are not free for commercial users. So most of these tools that are UI friendly are not for commercial users.
Correct.
So the last there is, I'm sorry, you wanted to add something.
No, there is a question that I already, I'm seeing it, can we call it AI? Yes, we can. Basically, AI algorithm that is used here, actually machine learning algorithm that is used here is supervised, which means that you need to give a lot of data to your algorithm so he can learn how to behave. And it's something that it's called weak artificial intelligence. That's true because it depends on so many things. You need to have a lot of data, you need to test that data, you need to train that data, but still if you reduced your manual task in terms that your framework knows what to do, you have implemented weak artificial intelligence. If we add a new functionality with new errors, yes, we need to handle that with this, let's say, supervised approach. But, and I think that's the most that we can do with the Selenium frameworks. But the question here and the note here is something that people out there who are working intensively on developing the tools that are going to support strong artificial intelligence is going to provide that. So basically that's it.
Yeah, I just want to add that maybe if we had millions of pieces of data, it would have a more confident outcome than this one, and we could build more complex systems. But with the data that we have as one company, this is far as we can go.